In this example, we need to use implicit differentiation to find dy dx. And the first thing we're going to do here is rewrite these cube roots in exponential form, just like this. Now we're going to differentiate. But remember, when we're using implicit differentiation, when we differentiate with respect to y, we're going to find the derivative of the y term, but then at the end of that term, we're going to add dy. Differentiating 25x raised to the 1/3 gives us 1/3 times 25x to the negative 2/3. But we also have to take the derivative of the inside of this expression, which is 25x. So we also need to multiply this expression by the derivative of 25x, which is 25. Now let's differentiate the second term with respect to y. The derivative of y to the 5/3 is 5/3 y to the 2/3 dy. And then when we take the derivative of the right side of this equation, the derivative of 36 is 0. And now let's clean this up a bit. In the first term, we have 7 times 1/3 times 25. That gives us 175 over 3 times 25x to the negative 2/3. Bring everything else straight down. Now let's bring the 25x to the negative 2/3 down into the denominator of the fraction to make the negative 2/3 a positive 2/3. And let's transform that back into radical form. So we would have 25x to the positive 2/3 in the denominator, but that's the same thing as the cube root of 625x squared, because 25x squared is 625x squared. Converting the second term back into radical form gives us 5 times the cube root of y squared over 3 dy. Now, you don't necessarily have to convert back from exponential form into radical form at this time, but for me, I think it's a little bit easier to work with things in radical form as opposed to exponential form while we work to solve this equation. Now the goal is to solve our equation for dy. Start by subtracting 175 over 3 times the cube root of 625x squared from both sides. Now let's multiply both sides of the equation by 3 to get rid of the 3's in our denominators. Doing that gives us this equation. Now let's divide both sides of the equation by 5. That gives us the cube root of y squared dy is equal to negative 175 over 5 times the cube root of 625x squared. Now let's reduce the fraction, negative 175 over 5. Now divide both sides of the equation by the cube root of y squared. And here's our resulting equation. And we can simplify this further by multiplying the cube root of 625x squared by the cube root of y squared. And so dy is equal to negative 35 over the cube root of 625x squared y squared. The second part of this question asks us to find the slope of the curve at the point 5, 1. To do that, all we need to do is plug in 5 for x and 1 for y into the derivative function. Here's the derivative function. Everywhere we see an x, we're going to plug in 5, and everywhere we see a y, we're going to plug in 1. That gives us negative 35 over the cube root of 625 times 25 times 1, which gives us negative 35 over the cube root of 15,625. And the cube root of 15,625 is 25. So now we have negative 35 over 25, which reduces to negative 7/5.